Neward, everyone.
Thank you. Thank you. One of the first insights I can offer is to start with the question, what the hell is it? So, polytechnical is a term I made up. Thank you for coming. Enjoy oh, sorry. No, I'm kidding. We're not done yet. I suppose I could do it with the end. There we go. Let's do the introduction all over again. My name is Ted Neward. How are you? So for a number of years, a number of friends of mine on the speaking circuit have been talking about polyglot, which is the idea that somebody speaks multiple languages. As a matter of fact, it gives rise to a basic statement about the world. We call those people who speak multiple languages, such as just about everybody in Europe, we call them a polyglot. Do you know what we refer to somebody who speaks only one language? American. Land of my birth. But in the software world, it's not just about the number of languages that you speak. There's a number of other considerations. And quite frankly, polyglot sounds like a really cool Latin word. So I looked up a couple of other Latin words, specifically the idea of making use of multiple forms of storage, that's polypreclusio, and the idea of working with multiple foundations or platforms, that's polycrepido. Now, all three of these things form what I would consider the heart of polytechnicism. That is to say, you know more than just one language, one database, one platform. That is really at heart the notion of being polytechnical, the fact that you have a breadth of knowledge. You've been to other places, you've seen other things, you have knowledge that perhaps your colleagues don't have. When you are polytechnical, you actually take a different point of view on the world. You see the value in different technologies. You can, even if you program in Java on a daily basis, you can look at C# and see that there's some interesting ideas there. You can look at Lisp and say, that's curious. I wonder why they chose to do that. You can look at the various, what we call NoSQL technologies and say, I wonder why they chose to build things that way. You can look at Perl and say, yeah, no, there's nothing good about Perl. Forget I brought up Perl. The point is, you're not limited to just the point of view of the technology that you might use on a daily basis. You are actually looking at a wide variety of things, and just as it's helpful to actually visit other countries and understand that not everybody in the world thinks the same way you do, it can be helpful to look at all these other technologies and understand that not everybody who writes code writes it the same way that you do. You embrace the idea that we can combine these tools in a variety of different ways to solve problems more elegantly than we ever would have with the single tool that you have at your disposal. You find yourself identifying with Karl Marx. Most people think that Karl Marx was speaking of socialism and politics when he was writing his various treatises and manifestos. He was actually talking about technologies. From each technology according to its abilities, to each project according to its needs. Never thought you'd hear an American reclaiming socialism, would you? But it's true. Think about even your modern web stack. Think if you just go back to the office and think about what you do on a daily basis. If you're building a web application, you're already polytechnical to a degree. You use HTML for your presentation layer. Well, technically HTML and CSS, because one is the description of what we want to display and the other is the description of how we want to style it. There's some JavaScript there in order to make your web page look a little bit more exciting. Maybe a lot more exciting, but at least a little bit more exciting. Then you've got whatever language you use on the back end. Maybe it's JavaScript, maybe it's Java, maybe it's C#, maybe it's Perl. And then where you store your data. As far as I know, nobody has yet figured out a way to store data in JavaScript. We actually store it perhaps in JSON, or perhaps we store it in some graph-oriented tree structure that we see but we don't necessarily interact with directly. Perhaps we store it in terms of tables. Perhaps we store it directly to the file system. Already, I've rattled off a half a dozen different technologies, and that doesn't even begin to count your build system. Because if you use Gradle, for example, you're using Groovy, and if you're using Maven, you actually envy the life of a Perl programmer. Because, yeah, Maven, XML, downloading the entire internet, the jokes kind of write themselves at that point. You recognize intrinsically the idea that there is no one tool that fits all of the possible things that you could possibly want to do. That in fact, we already are making use of a variety of different tools and a variety of different technologies. But you think about it for a second, and you say to yourself, well, I mean, Ted, that may work for you, because you're a speaker. You're spending your time sitting on a rock overlooking a mountain valley, contemplating the universe. You're a philosopher, perhaps. You're somebody who can afford to spend time thinking about all of these different things. And let's be clear, the Polytechnical path is not free. It's definitely one that comes with a lot of different costs. For starters, there's an increased complexity here. If all of our technology, for example, was JavaScript, then theoretically, hiring somebody to replace the person who just walked out the door is easy. We just find somebody who knows JavaScript, right? Because people who know JavaScript are just hanging off of trees. We can just reach up, grab one, put them to work, and there's no other training required, right? I mean, it's not like knowing JavaScript, you immediately know all of the code, all of the libraries, because there's only like one framework in JavaScript, right? Right. Yeah. Because even if you know that one language, of course, there's tens of thousands of different packages within the JavaScript world. And of course, the JavaScript world, if for whatever reason you wake up in the morning and you feel grumpy, you start a new framework. Because you're JavaScript, why not? I mean, the fact of the matter is, it does introduce a significant level of complexity, particularly if you start to combine languages that aren't similar to one another, right? The main reason that JavaScript is named the way that it is because when they created the language, Netscape said, well, this Java thing looks to be pretty ascendant, looks to be pretty popular. So when you go create your scripting language, please make it look like Java so that other people who are familiar with curly brackets and semicolons will be able to understand this language. So the creators of JavaScript basically created a Lisp, put curly brackets and semicolons in it, and confused everybody for 20 years. If you think about it, and you think about all the technologies I just rattled off, HTML, JavaScript, CSS, SQL, XML, etc., I'm telling you to go learn more. I mean, very few people consider themselves to be an expert in any one of those, and I'm telling you very deliberately to go off and learn more because you already have too much free time on your hands, right? Right. So think about that, right? Who's really got the time to learn all of those things? And on top of that, assume you walk out of here and say, this is really inspiring. I love this. I'm going to figure out how to use Java, Haskell, Perl, and Go all on the same project. Just as a show of hands, who wants to be the person following that guy on that project? Show of hands. There's one woman back there who's like, me, pick me. I don't know what they are, but they sound interesting. Besides Perl, I already know you're lying. This is a tremendous degree of interoperability issues that you have to figure out. How exactly is Go going to call Java? How exactly is Java going to call into Lisp? How exactly are all of these tools going to work together? There's a technical complexity that needs to be considered here. And on top of all of that, if you believe that the Go programmer is going to solve a problem the same way that the Java programmer does, you're basically thinking that an American will think the same way as a Greek, or vice versa. And Donald Trump has demonstrated that nobody knows what an American is thinking. There's a lot of costs involved with this idea of doing Polytechnical. So, when would we think about this? Well, there are a number of interesting scenarios that emerge, depending upon how you want to think about this. For example, have you ever been part of a project where people are routinely requesting changes? Imagine for a moment you work for Amazon.com, and in the time when Jeff Bezos isn't building new spaceships, he asks you to add some code to the website so that if somebody orders a genuine imitation lightsaber in response to the fact that episode 9 is getting ready to come out at some point, or maybe you're going to buy an infinity glove off of Amazon, and for the next 2 weeks only, if you buy the infinity glove, and if you are an Amazon Prime member, then we will also send you a genuine Black Panther mask, but only if you live in the state of Washington, because marketing thought that was a good idea. And this code is only going to be there for 2 weeks. And in the meantime, marketing also has a new request to happen 3 days after that, because there's a new romance novel coming out. And we also want to offer the opportunity that if you buy one novel, you can get the second one for free. Or we want to identify those people who are iPad users, and we want to offer them the opportunity for a free stylus, et cetera, et cetera, et cetera. All of these simple code changes, but it's a lot of them. They require testing. How are you going to solve that? I submit to you that in fact, part of your solution here is to recognize that there are two fundamental problems that you're trying to deal with on this particular project. One is keeping the website up and running and being able to process transactions and so on and so forth. The other is engaging in some sort of basket filling. There are always going to be special offers. There are always going to be special deals. There's always going to be something that the marketing department wants to offer. And every single time they come to you, the developers, and say, please make this change, they're taking away time from what you should be doing, which is building resiliency, redundancy, recoverability, et cetera, into the real core of the site. What if the marketing department could take care of those changes themselves? What if we could give them a small sandbox in which to play, give them a simplified language with which to use, and let them solve their own problems? Microsoft had this same solution years ago, and they called it the Word Scripting Language, VBA, Visual Basic for Applications. Give them a scripting language, plug it in, surround it in a sandbox so there's no security concerns, and within it, let them do whatever they want. New problem. You quit Amazon and you go work for, I don't know, McDonald's, because they're hiring. McDonald's actually has an extremely large IT infrastructure that they use. And one of the things that McDonald's would like you to do is they would like you to build a piece of software for their managers to use to schedule their employees. Now remember, these employees are all part-time people. They don't work just 9 to 5. Some of them come in at 5 in the morning and leave at noon. Some of them come in at 9 in the morning and leave at 3. Some of them come in on Monday and Wednesday and Thursday. Some of them come in on Tuesday and Wednesday and Friday. Some of them can only work on the weekends. Some of them can only work evenings. Some cannot work on Mondays. And you need to write a piece of software that knows how to take all of these different permutations and figure out a schedule. Who's down for that? How about, let's take a simpler problem. I want you to build me a program that knows how to solve Sudoku. You're familiar with Sudoku, right? It's that number puzzle where you've got to figure out, you've got a square, and it's got 9 squares inside of it, and inside of each of those squares, there's 9 more squares, and you have to make sure that each number only appears once in that bundle of 9 squares, but they can only appear once in each row and only once in each column, etc. Who wants to write a program to solve that? Couple of hands, braver souls. You can do it in less than a page of code in a language called Prolog. There are languages out there called logic languages that are specifically geared towards being able to take this notion of multiple permutations and recursively try each one until we end up with one or more answers. Prolog was built for that. Attempting to do it in an object-oriented language is going to take weeks, if not months, and you're going to have to try a number of different permutations to see if it works. The Sudoku solver is an example sample that ships with most Prolog implementations. And there are a number of these kinds of logical, permutational kinds of problems that will show up frequently under the heading of business rules. If you've ever tried to rent a car from an American car company, you know exactly what I'm talking about. Because if you rent the car on Tuesday through Thursday, it will cost you $59 a day. But if you rent the car Monday night through Thursday, it will cost you $39. Or, I will never forget this story myself, I was flying into Oklahoma City, Oklahoma. If you don't know where that is, it doesn't matter. It's in the middle of the US, where they all kind of talk like this. They got that lovely southern accent. And I was renting a car for the week training I was going to do. And I'm speaking with the Hertz representative on the phone. And she says, "Oh, you're coming in Sunday night. We don't have any cars available." And I'm like, "Oh, crap, really? That kind of sucks." Because I'm a Hertz Gold member, and I've got a number of cars, a nice frequent history with them, blah, blah, blah. We're talking about some possibilities. And all of a sudden, the representative says, "Well, now hang on. Let me see something here." Clickety, 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 clickety. All right, here's what we're going to do. We're going to make this reservation for Monday at midnight. So in other words, in the middle of Sunday night, midnight, that's technically Monday, we'll make the reservation starting Monday. She says, then what you do, because my flight was getting in about 6 p.m. or so, she says, then what you do is when you get to the airport, tell them that you're here early because you're allowed to pick up your car 6 hours in advance of the reservation. You'll have to wait a few minutes for them to find a car for you. And I'm like, now, hold on a second. You don't have any cars for Sunday night, but magically one will appear at midnight on Monday and then move forward in time 6 hours? And she just kind of laughed and she said, "I just do what the computer lets me do." Business rules, we call them. And when you don't implement the business rules precisely, the people who use those systems figure out how to game the system to their own benefit. And I did it. I took it. I knew full well as I drove away in that car at 7:30 p.m. that there was going to be some guy coming out of the airport at like 11:45 p.m. and he's going to be pissed. And I didn't care. Because there is nothing in Oklahoma City that you can get out by the airport. So I needed a car. These logic languages give you the opportunity to implement these business rules in a very declarative manner. In some cases, the logic, the business rules, are rules that you and I are never going to figure out. One of the projects that I worked on was actually implementing a new accounting system for the University of California. Not the whole system, but this is a 10-campus system across the entire state of California. Each institution is itself a billion-dollar institution. And the system that they had been built back in like 1992 with something that was basically the equivalent of like Power Builder. And it was a mess. It was an absolute mess. And I sat down with some of the business analysts and I said, okay, explain to me what needs to happen when somebody wants to issue a purchase order. Some professor wants to buy a computer. What exactly happens? And the first words out of their mouth were, well, depending on which professor it is and depending on which department they're in, the workflow here may be a little different. And I said, wait, how many departments are there on campus? She said about 60. And each one of them has a different workflow? Yes. And you know all of these? Yes, more or less, except when the departments change them and don't tell us. And I said, is there anybody in this room, as I'm looking around a room of about a half dozen people, is there anybody in this room who knows all of the business rules regarding these workflow processes that these different departments stand up? And everybody kind of looked at each other and they kind of laughed. That's not a good sign. When you ask a question of the business analysts, of the experts, and they laugh at you, that's really not a good sign. Because now you as the developer are effectively signing up to be the one to know each of those different workflow rules, because we have to understand the business domain in order to put it into code. Unless we don't. This is where we get to the whole notion of the domain-specific language. Can I build a tool to let them express their particular business rules, to let them express their workflow in such a way that I can remain ignorant of it, they can retain control of it, and they can, in fact, debug it even, particularly if I give them a little sandbox in which to test some of this stuff. We built a custom workflow engine, and lo and behold, now the departments actually, if they had somebody who was of sufficient technical skill, they could actually write their own workflows. So we actually not only ported the system, but we gave them additional control that they didn't have, which made them very, very happy. In some cases, the requirements that we have to deal with, they don't fit naturally into a paradigm. How many people in here are familiar, comfortable with the concept of a relational database, tables, SQL? Show of hands. Yeah, good number of you, most of you. Now, what I would like you to do is I'd like you to build for me a genealogical database. I would like you to build for me a relational database that can keep track of your family tree. Who were your parents? When were you born? Who were your siblings? When did your parents get married? And if this is the US, when did they get divorced? When did they get married again? When did they get divorced again? What other people did they marry in the meantime? And if we're in Utah, how many wives does your father have? Who's ready to do that in a relational database? There is a book by a gentleman by the name of Joe Celko, C-E-L-K-O. If you want to go find it, it's basically, he's written a number of books. One of them is called SQL for Smarties. But the other one that he wrote is talking about trees, how to express trees in a relational database. And I swear to God, the book is about this thick. And what's even better, his picture is on the back cover, and he looks like a Marvel villain. He's got the shaved hair and the goatee, and he's looking at you like, are you man enough? Yeah, genealogical, graphs, trees, this is stuff that doesn't really fit the relational paradigm. You can make it work. You can definitely make it work. You can create a table that has all of these relationships, the person table that has all of these foreign key constraints to the person table again. But then usually what you end up doing is you end up creating some sort of metadata store. You start saying, well, instead of just trying to use the relational database directly, I'm actually going to create a table of relationships, so that a person can have a one-to-many relationship with relationships. That's kind of meta if you think about it. And that relationship table will perhaps have some data. And now when you want to express a query that says, find me all of the people who are named Ted, whose grandfather is also named Ted, and was born in Claremont, California, how are you going to write that SQL query? You're not. What you're going to do is you're going to build a whole bunch of code to express a whole bunch of separate SQL queries in order to pull that data together. And any notion of relational integrity is out the door. But if you know a graph database, Neo4j, for example, GraphQL perhaps, then you already know how to do this, because that is its natural state of being, is storing things in a graphical fashion. Or if you wanted to build YouTube, you wanted to build a website that has all these videos, are you going to store potentially megabytes or gigabyte-sized videos in a relational database? Even Amazon knows better than that. They give you S3, they give you Dynamo, they give you a number of different data tools to be able to store a variety of different kinds of data, because one size doesn't fit all. Or perhaps you run a team. Perhaps you're a manager or team lead, and you go out looking for new programmers, and to your surprise, hiring senior developers is hard. They're not just there on the street holding up a sign, "We'll code for food." They're not just waiting for you to make them an offer. In some cases, you actually have to lure them away from the company that they're at. You have to promise them things like free sodas, parties on Friday, massages. You have to promise them, oh, I don't know, we could get really, really crazy here, and most of you would believe it. We could promise them free trips to Cancun. He's interested. He's like, wait, Cancun? I'm available. Tequila. So do you get the team that you want, or do you get the team that you can get? In many cases, we're not going to be able to staff our team with a whole bunch of all-stars. We're not going to be able to create a team of the best and turn them loose. And as a matter of fact, in some cases, I really wouldn't want to anyway, just because of the egos involved. So instead, what I have is a team of people with a variety of disparate skills. Some people are brand new. All they know is HTML. Some people are programmers who have been doing this for 10 or 15 years, and they've got familiarity with Java and HTML, but they don't know Bootstrap. They don't really know CSS. And then occasionally I pick up a database engineer who's really, really good at working with data and establishing some really good queries and being able to tune all of that. And somehow I have to weld all of these people together and to make the project work. Sometimes I don't choose the technology. Sometimes the technologies choose me, because I have to work with what they know, because I don't have time to train them on whatever it is I want them to know. Now, I've talked to a number of managers over the years when I've done some consulting, and when I tell them all of this, they look at me and they're like, nope, it'll never work. You can't just weld random technologies together. Except you can, as the Republicans found out in 2012. When Barack Obama, oh, how I miss that man. When Barack Obama decided to go for re-election, they realized that they needed to bring together a variety of technology to bear. Barack wanted to make use of data science and analysis and so forth to try to figure out where he should spend his efforts in order to secure his election. What they ended up building was something that could process 4 gigabytes a second, 10,000 requests, 2,000 nodes across 3 data centers, 180 terabytes worth of data, 8.5 billion requests, 583 days. Introduce everybody, design, deploy, dismantle. Because once he's elected, we don't need this anymore. 583 days, 18 months. A team of complete strangers came together, bringing whatever skills they had, because remember, this was an all-volunteer effort. They managed to weld it all together, ship it, sink his opponent, and then dismantle it. 18 months. Don't tell me it can't be done. Now, there's some of you in the audience who are like, all right, I'll buy this in the abstract. But tell me how this will actually help me as a programmer. Tell me how this is really going to affect my life in a direct and meaningful way. How would learning Haskell, for example, make my life better as a programmer? All right, challenge accepted. This is Haskell. Specifically, this is a Haskell list. In this case, it's a list of 3 numbers, 1, 2, and 3. You guys got that? Good. Some of the things we can do with Haskell. Haskell, remember, is a functional language, so we don't hold much truck with objects. Matter of fact, Haskell doesn't really have the concept of objects. Haskell is a pure functional language, pure in the sense there are no side effects, and pure in the sense that we don't need no stinking objects. Head numbers says I want to peel the first element of the list off and return that. Now remember, that doesn't affect the list at all. It just returns the first element from that list. And similarly, last gives me the last number in that list. Okay. Tail will give me everything that's not the head. And take will let me take some arbitrary number. So when I say take 2 numbers, it says specifically, I will peel off the first 2 numbers off of that list and return it as a list. Still with me? Good. Let's keep going. We can create a list out of a range of values. So here we see 1,100. Because if I were to have to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you're bored already, aren't you? It's even more boring, type that out. So we use the range operator to say we want to pull everything inclusive of these 2 numbers. So this becomes a list of 1 to 100. Now the other thing I can do is if I specify 2, 4, Haskell looks at that and says, aha, you want every other number. So evens down there will be 2, 4, 6, 8, 10, 12, etc., all the way up through 100. Okay? Cool, let's keep going. Now, there's another way in which I can create a list. I can actually use what Haskell calls a list comprehension. I can say specifically, let me apply a function, if you will, to create that list. So here, for example, other evens is going to be a function that says, let me get x, and I'm going to take 1 through 10, and I'm going to send it to x, and in this case, I'm not going to do anything. So technically, other evens is a lie. That's just another list of 1 to 10. It's not even even numbers. But below it, we see squares. And notice, on the right-hand side of the vertical pipe, I still take 1 to 10, and I put it into x, and for each one of those numbers, we do what's on the left-hand side of the pipe, and in this case, we square it. So this gives me a list of the first 10 squares. Now we can use this list comprehension because Haskell says everything is code. So here in FizzBuzz, remember FizzBuzz, right? That's the simple exercise that they ask you during interviews that says go through a list of numbers from 1 to 25. If the number is divisible by 3, print fizz. If the number is divisible by 5, print buzz. If it's divisible by both, print FizzBuzz or BuzzFizz. I can do that in one expression in Haskell, because here the if statement, if x modulo 5 is 0, else if x modulo 3 is 0, and in this case I actually throw in just a quirk. Let's actually say x modulo 4 is 0, otherwise just return x. I actually have an improved fizzbuzz. And then, of course, down below, we see I take 1 to 25, I apply it to x, and we go through this 25 times. That's called a list comprehension. Similar in concept in some ways to a for loop, but different, because I'm actually creating a function and applying it to each element in a list. I can also create what Haskell calls an infinite list. The one ... creates a list that will never terminate. Now, those of you who have ever had a for loop run away, you know that usually what happens is not good. If you've ever taken a for loop and used it to try to populate an array list with an infinite number of numbers, you begin to discover how good the Java garbage collector really is. And the answer is, when there's no garbage, not very good. But Haskell's okay with this. Because Haskell says, you know what? Just because you want the list doesn't mean you get it right now. I can have code hanging out here in the corner that is just waiting to give you the next number, so that when you ask for the first number of the list, I'll give it to you. And if you ask for the second number of the list, I'll give it to you. And so on, and so on, and so on. I don't have to realize the list immediately. A list is not the same thing as a collection. And to sort of reinforce that, Haskell introduces a concept called cycle. This is a function that will literally continue to increment across the contents of a list infinitely. So here, if I want to simply cycle on love, and then I can take the first 3 elements, I get love, 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 and I sound like a Beatles song. Still with me? Cool. It's kind of silly, isn't it? The notion of an infinite list. I mean, seriously, where in God's creation do we see an infinite list? I mean, technically, the number of stars in the universe is finite, or so the astronomers think. It's just a really, 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 really big number. The number of grains of sand on the beach, finite, even though it's a really, 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 really big number. When would we ever need to have a collection that goes on forever? What a stupid idea. This must be why Haskell is not as popular as Java. Haskell calls those infinite lists streams, by the way. And if that's causing some alarm bells to go off in the back of your head, it should. What if? If you think about it for a second, these notions of having a function that can produce the next element on demand, in Java terms, that's like having an iterator without a collection. Usually we think of iterators and collections as side by side. You have to have an iterator to walk through the collection. But what if you could have an iterator without the collection? What if the iterator knew how to magically produce the next value you were looking for? For example, what if, for whatever reason, I wanted to have an infinite collection of even numbers? I could create something that implements the Java iterable interface and produces an iterator that keeps internally a count. And every time you call next, we increment the count and then increment again so we get an even number. And every time you check has next, in this particular case, I've decided I don't want that to be infinite because eventually we'll overflow an integer. I, in this case, have arbitrarily decided to say, let's keep this of a list of evens from 2 to 100. But I could make that 10,000. I could make it 10 million. How much memory does this collection occupy? One int. I don't have a collection of 10,000 or 5,000 or 100,000 numbers. I have an iterator that knows how to produce the next value on demand. And I hold just enough state to know what the next value should be. And you say, okay, fascinating, so what? Well, using this iterator would actually be pretty straightforward, right? We could use the for loop directly without getting any of the other functional stuff that Java might provide. And by the way, this code does not require Java 8. You can do this as far back as Java 2 if you like. How many of you have ever tried to read a file in Java? Yeah, pretty much all of us. That like page and a half of code. And if you try to read the whole file up front, you have to have room for the entire file in memory, or you get these really, really complicated caching strategies. It would be really nice if I could just demand the next line whenever I needed it and not have to pull in anything more than just the next line when I needed it. If I had something that knew how to produce the next line on demand like an iterator. File iterator wraps around a buffered reader. And every time you say next, it reads the line. Now you'll notice the drawback to this, of course, is if we eventually catch an I/O exception, we just set the line to null. And that could be a problem because I know everybody in here catches exceptions correctly, right? Nobody has ever in their programming career written catch, I/O exception, parens, parens, curly bracket, slash, slash, we really should do something with this someday, close bracket, right? All of you faithfully handle that exception and signal it to the user in an appropriate way, right? Right. Right. And next you'll be telling me Perl isn't terrible. And thus, do I read a file? Think about the code that you wrote to read a file, to loop through that file, to find lines that met some particular criteria. Was it this simple? I submit, no. All I did was teach you Haskell lists. That's it. There's a lot more to Haskell to learn, by the way. I taught you a basic, fundamental premise of Haskell. And out of that, we discovered something really interesting, that this concept of the infinite list is not about just somehow occupying a ton of space. It's not about some weird esoteric property of mathematics. That the really interesting part about these infinite lists is the idea that I have code that knows how to produce the next value on demand. 10 minutes listening to me blather on about this pure functional language, and you now have an interesting concept that you take back to Java. By the way, it works just as well for relational databases too. Wink, wink, nudge, nudge. Some of these ideas were not my creation. As a matter of fact, I'll let you in on a little secret. None of them were really my creation. Google had sort of figured some of this stuff out in Guava. They have the iterables class and the iterators class, which capture a number of these things, because people at Google had looked at functional programming and said, there's some interesting ideas here that we'd like to capture and express inside of Java. And then Brian Getz, who is always willing to let other people be his laboratory while he looks for ideas that he wants to capture and pull into the Java language, he said, yes, the time is right. Let's bring this into Java 8. Well, technically we wanted it in Java 7, but you all know how that story turned out. And we call them streams. And what's even more interesting about streams is once you begin to understand the notion of functional programming, and once you begin to understand that the for loop is the biggest violation of dry, the don't repeat yourself principle, once you understand that, then you begin to understand that we want to actually take these functions and apply them to collections, And from there, it's a very short step to figuring out I don't have to do those sequentially. I can actually do them in parallel. And then you're ready. Then you're ready to understand parallel streams in Java 8. But think about the infinite stream again for just a second. I began that concept by saying there are no such things as infinite streams. There is no place in our universe where something is actually infinite, except maybe my ego. But what if we squint kind of hard and we say it's not about the actual objects we deal with in the real world, but what about events? What about time? What about the idea that there will be things that are happening? What about, I don't know, mouse move? Will the users ever run out of moving the mouse? Nope. Will they ever run out of clicking it, double-clicking it, shaking the mouse because they don't think the click actually worked? Will we ever run out of user stream data? Well, yeah, as soon as they close the program down, at which point we don't care anymore. Will people ever stop buying stuff from Amazon? Not as long as America's around, we won't. What if we look at the world as a series of infinite events? And what if everything that we're doing, MVC, putting stuff into a database, taking it out, etc. What if everything we're doing is in response to a user doing something? Think about that for just a second. You build an e-commerce platform and nobody comes. I mean, that's kind of sad, don't get me wrong. But what if we built a thing and no users come to use it? Is any of your code going to execute? Probably not. You may have a few time things that says every day, let's go look to see if there's something in the database, and then react. Because that thing in the database is itself a stream of events. Everything is a stream of events to which we write code to respond. If you can wrap your head around that, then congratulations. You have just taken your first steps to understanding functional programming, reactive architectures, React, period, Redux. And I can say to you that the user interface is the result of applying state to a function. And if you can get that, and then you see that each time we change the state because the user has done something and we produce a new user interface, congratulations. You just understood React. You don't have to know any of the syntax. You don't have to know any of the libraries. You get React. Because that's the concept that's at the heart of React. Feels pretty good, right? Because now you can all go home and put functional programming on your resume. Voxxed Days is giving you good value. So how do we do this? If all of these benefits are there for the Polytechnical programmer, how exactly do you do this? Well, for the individual, you need to embrace the concept of the Tshape. Recruiters will sometimes talk about this. If we think about you, and if we think about the depth of your skill set, in terms how much do I know, I might be able to go really deep on Java. And we don't actually want I-shaped individuals. Somebody who's really deep on a particular thing. They may be useful as a temporary consultant. For example, I might hire Heinz to come and work with my team in order to teach them how to best make use of Java and the JVM, how to best do some performance tuning, and then after that week or two, boom, out he goes. Not because I don't like him, he's a lovely man, but because As much as I love him, he didn't know anything else. He's an I-shaped individual. Heinz is looking at me like, fuck you. Yes, I do. And I'm bigger than you. I'll kick your ass in the parking lot later. But you get my point. If you only know one thing, the amount of situations to which you can be applied are much, much smaller. But at the same time, you could have me. I know a little bit about everything. Seriously, I know a little bit about everything. If you walk up to me, well, I take that back. I know everything except Greek. Because if you walk up to me and ask me a question, I will respond in that time-honored fashion, I don't know, it's Greek to me. Yeah, I can actually use that joke here in Greece. No? All right, fine. The point is, I know a little about a lot of very different technologies, but Heinz's knowledge specific to the JVM vastly eclipsed mine. You want to be somewhere between me and Heinz. You want to be the T-shaped individual. You want to have some things in which you have some depth, but you also want to have a variety of other things in which you have a little bit of depth, some knowledge. And obviously, the best thing to do, because you want to improve the surface area under this graph, you want to go a little bit deeper in the things that you've chosen to study more deeply. And you want to go a little bit more broader in order to be able to pick up things that you don't already know. Case in point, I know as much Bootstrap as everybody else in here knows. I know enough Bootstrap to make my website look like every other website on the planet. Because that's what we use Bootstrap for, so it doesn't look like it's a straight HTML page. We get the hero and the bar across the top and the hamburger menu. I know how to do about that much. My knowledge of Bootstrap is about yay deep. I have some knowledge of CSS, enough that I know kind of what I want to do, but then I'll go look things up. I'll go read a book when I want more. I know enough of CSS to know that I don't know it particularly well. Which leads us to my first little bit of philosophy, which is to say there are three kinds of knowledge in the world. There are those things you know that you know. There are things you know that you don't know. And then there are things that you don't know that you don't know. Many of you knew that Haskell was a programming language, but you had no idea what it looked like. Today, you know a little bit more about Haskell, but you're still not Haskell programmers. But I'd be willing to bet you that none of you are aware of the fact that there is a programming language called Shakespeare. It is a programming language which literally reads like one of Shakespeare's plays. And apparently somebody back there doesn't like Shakespeare. This was a fact that you didn't know that you didn't know. And now you know it. And now something really esoteric, don't bother with it. It's something that now moves from category 3, you didn't know that you didn't know, into category 2. If you're going to be Polytechnical, your goal is to move as much as possible from category 3 into category 2. Whether or not you choose to take it from category 2 into category 1, that's going to be a personal choice. That's going to be a question that you're going to have to answer depending upon the context, depending upon your job, depending upon what sounds interesting, et cetera, et cetera. But when you sit down to learn a technology, you say, wow, you've got all these languages in your head. How do you keep them straight? Well, the answer is I've categorized them. The talk right before mine was talking about RDF and ontologies and the notion of how we structure language. That's actually a deeply philosophical point. How do we think about knowledge? What is knowledge? How do we structure it? For you, your insights into a particular programming language may be different than mine, and that's fine. That's completely okay. Because what you want to do is you want to figure out your own ontology for languages and for databases and for platforms and for any other technology you can think of. When we start thinking about augmented reality and virtual reality, I say those are just additional user interfaces. It's just another way of being able to generate that infinite stream of events that we as programmers are going to have to respond to. Whether I do it like this, or whether I do it like this, or whether I do it like this, I don't care. They're just a UI. Now, you may agree with that. You may disagree with that. I don't care. Because your ontology is your own. You have to figure out what these technologies mean. You have to figure out what they mean to you, your career, the world around you, whatever. It has to be something that comes from you. Now, you might listen to myself or Venkat or Heinz or some other folks and hear what they have to say, and you might take some of that in and go, that makes sense. Yeah, I can agree with that. But that's just you building your own ontology. What do these technologies mean to you? If you go, however, and you just keep looking at the same stuff, you know Java, so you decide to go learn C#. C# is boring. C# looks like Java should. I mean, they added a bunch of interesting new language features to Java. Java will catch up eventually. I mean, C# has had lambdas and streams and so forth since C# 2.0. And they used that, and they built some other interesting stuff on top of it, language integrated query, etc. But at its heart, C# is just another object-oriented programming language, statically typed. JavaScript, well, it's another object-oriented programming language, but it's dynamically typed, but it's also prototype-based. We don't have classes in the same way that we do in C# and Java. When we create an object, we ask an object to make a clone of itself. There are other languages that led the way there. If you really want to learn a language, go learn something that's radically different than you already know. Go learn Elixir. Go learn Scala, Clojure. Go learn Self, Simula, ML. Go pick up a language that's still being developed right now as we speak called Ballerina, which has a vaguely Java-like feel to it, but does away with objects and adds JSON and XML as native data types. Oh, and treats services as a thing, and understands HTTP natively, because the whole purpose of this thing is to let you build web services at the language level. What does that do to change things up when I can look at XML, JSON, oh, and I forgot to mention, the relational database. When I issue a query, I get back a table object, which is something that Ballerina understands natively. How does that change your programming style? Don't go for the stuff that's familiar. Go for the stuff that's different, because that's where the really interesting dissimilarities are going to come from. Oh, Dad, you're signing me up for a ton of work here, man. Seriously. I don't expect you to become an expert. I'm not an expert on Haskell. I know enough of Haskell to have gotten some interesting stuff out of it. Learn just enough to answer a particular question that you want. It's what I refer to as an evaluation function. You want to have some little pet project, some little idea, something larger than Hello World, but something smaller than anything you would ship. If you're of a religious sort, for example, you might decide to build a directory for your church so that everybody can keep track of who else is in here. Or maybe you want to build some sort of prayer chain application. If you're a sportsman and you're a part of a recreational league, build a league to track statistics for the various players in the league. Nobody has to actually use it. It just has to be something that gives you a reason to write code or to experiment with data. Create an evaluation function and run each technology through that evaluation function. Sit down, write some code with it. Doesn't have to be pretty, it doesn't have to work. It just has to be enough for you to get your hands dirty with it so that you can start to see whether or not this thing is interesting. Because some of them won't be. You'll look at some of them and you'll be like, oh, this is, I just can't. That was my reaction to Perl. I just can't with Perl. Because that's the thing, is your time is precious. My time is precious. I looked at Perl, I played with it for a while. I realized one day when my cat walked across the keyboard and it looked like Perl, that I didn't care about this technology at all. I just didn't. It just, I mean, literally, Scooter went bonk, 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 and I looked in the editor, I'm like, I think that'll work. Just don't care about Perl. You may look at Clojure and say, oh, I don't get it. That's fine. You looked at it. You understand a part of it. Move on. Your time is precious. Don't waste it learning something that you don't see any value in. And you and I may disagree. You may look at Perl and go, how does he not love this language? I don't like broccoli either. Fight me. We all have different opinions. It's okay. But what if you're the manager of a team? What if you're running the business? Over the last 5 years, I've actually made the transition from developer to manager. Currently, I run 2 teams at the company, Smartsheet. One of them is a team of developer relations, developer evangelists. They go out at conferences and they speak at events, and anybody who's interested, we talk about our API, et cetera. The other is an engineering team. How do I foster in them this learning space? How do I get them to be polytechnical? Well, for starters, find them and encourage them. You're looking at a resume, and you see somebody who's got C# for 5 years, and you're looking for somebody who knows Java. They know Java. They don't know how to run IntelliJ, or they might, because IntelliJ now has a C# IDE, and IntelliJ actually created a plugin for Visual Studio for doing refactoring. They probably understand IntelliJ relatively well, but you know what? If they've been doing C# for 5 years, they'll pick up IntelliJ. Hire them. Assuming they want to be hired, of course. But if they're submitting to a position where you're looking for a Java developer and they have a whole bunch of C# experience, Python experience, if they've got Node.js experience, don't look specifically at the language. Don't assume that people are commodities. We just need to find the right part and shove it into the machine. Encourage their curiosity. Hire them. Encourage them. Give them the opportunity to learn Java and teach you a little C# in return. As a matter of fact, not only encourage them, tell them to disagree with you. I'm sorry, what? You want me to bring people into a meeting specifically to disagree? Yes, it's called establishing a culture of dissent. Do you know when the biggest disasters in mankind's history have happened? When a bunch of people sitting in a room all looked around at each other and went, yeah, that sounds like a good idea. Whether they're architects in the architectural committee, or whether they are the engineers for the Space Shuttle Challenger, or whether they are the command staff of the USS Titanic, in each of those cases, there was a condition known as groupthink. John F. Kennedy fell into the same problem when he decided to go forward with the Bay of Pigs, the CIA invasion of Cuba. There were all kinds of signs that this was never going to work. But everybody in the room was afraid to disagree. If you really, really want to encourage a culture of learning and a culture of growth, swallow your fear and be the one to disagree. I've been friends with Venkat for 18 years. We have a lot of stories, but one of our favorite ones that we love to tell is when Venkat and myself and 2 other developers, we were in London for a show, and we went out to a pub, and I think it was Neil Ford made some comment about how checked exceptions are absolutely stupid and there's no reason they ever should have been designed. And I said, that's full of shit. Checked exceptions are marvelous. They were a great idea. We spent 5 hours in a random pub in London arguing checked versus unchecked exceptions. Why? Because it was a fascinating argument. But more importantly, we learned and exchanged a whole bunch of interesting ideas, all because I was willing to look at these other 3 people whom I deeply respect and admire and say, you're full of shit. It's actually quite surprising that I have any friends whatsoever. But part of it is, if you're a manager, you want to tie this notion of Polytechnical to business goals and constraints. How does the business benefit from having these different technologies in place? You can't, you could just say, we should go learn Ruby on Rails just because, but you have to establish some goals. For the engineering team that I run, we run 2-week sprints. And from the very beginning, from before the team lead himself was hired, I said our sprints are going to start on Tuesday and end on Thursday. So that the first Monday and the second Friday are your time. Do whatever you want with it. Learn whatever you want. Have the meetings with HR. Take a day off. Whatever. That is your time to spend learning whatever. Now, the rest of the time during the sprint, please focus on the stuff that we want you to work on. But effectively, this is that Google 20% time. I don't expect them to build stuff that will be interesting to the company, but I do expect them that they'll spend some time learning. As a matter of fact, in the last sprint, my team decided that they were going to go back and do something of a refactor. They took their 2 days and voluntarily went back and refactored a whole bunch of code because they thought it was ugly. Wow, guys, all right. So we learned a little bit more about how to do code reviews and refactoring. Winning, I love it. What is your core business? Seriously, if you're a developer at a company and you cannot answer that question, how does your company make money? You are dangerously short-sighted. You need to know that. Because then you can actually take some of these technologies. You could say, manager, boss type person, I noticed that what we do is we actually encourage people to buy stuff. We're one of those digital marketing agencies. And I was just looking at this VR, AR, whatever technology, and I was thinking this could actually be useful. This might be something we want to make use of. Because I know that our core business is to get people to buy stuff. And maybe if we build a couple of AR apps, they'll download the app, they'll see our logo, they'll be curious to find more, they'll pursue. Or maybe you work for a consulting company and you say, hey boss, right now Elixir is really hot. Maybe we should look into it, if only because that's where the cool kids are hanging out and we're always looking for more people to join our consulting company, or whatever. Figure out what your company does to make money. And then figure out how different technologies can help with that and tie the two together somehow. Lastly, remember that we are not machines. Your project team is not a machine. You are not looking for resources. You are looking for people that are human, that have emotions and feelings. Put the human back into this. When you hire somebody, ask them point blank, what do you want to do? What do you want to be when you grow up? And if some of them say, I'd like to be a manager, then work with them to improve their management skills. And if some of them say, I'd like to learn how to program in C# or .NET, then set them up with the necessary courses, tools, send them to the appropriate conference, encourage their growth. Because even if they leave you, they'll remember you fondly, and more importantly, they'll probably leave you because somebody else inside the company can make use of them. They'll leave your team as a team member, and they'll go work over there as a team lead. And they will carry your teachings with them, and they will start to instill that as part of that company, and you will be implicitly broadening and improving the company. And suddenly when your boss looks around and says, hey, I have a promotion to hand out, who has made the biggest impact on this company? It's you. This is not easy. I do not want to stand up here and promise you that you can just sort of gallivant down this path and it will all be rainbows and unicorns. There will be people who don't get it, and you'll either have to teach them or work around them. There will be people who will tell you you're stupid. Just assume they're a Perl programmer. Move on. The point is, if you do this, you will find insights faster. You will be able to do designs better. You will be able to master new technologies more quickly. And you will find your career accelerating. Peace.
Let's take some questions.
Oh, not from that guy.
Hey Ted, since you encourage dissent, I would like to disagree with you regarding the rules engine. In my experience, bringing up a rules engine into an organization to let the customer handle their business rules, well, in the end, nobody is able to change anything because the customer doesn't understand the rules engine and the IT crowd doesn't understand the business. So in the end, it's just a terrible mess.
So, without...
It was not a question, by the way.
No. The question was, Ted, I think you're wrong. Am I wrong to think you're wrong? And the answer is yes, you're wrong.
Okay.
Any technology when brought in has to be managed carefully, and I'm going to leave it at that.
Shall we take a few more?
I think people want to get prizes.
People want to get prizes. We're going to give them prizes for sure, but let's take a few more questions.
And beers.
And beers.
A quick question about the second worst language you have to offer.
The second worst language? I don't know, Perl is so bad, it's kind of blotted out everything else in my memory. Probably the language will be Malbo. So Malbo is a collection of those languages known as esoteric languages, and specifically the language is designed to screw with programmers' heads. It's worse than the language called brainfuck. So yeah, we'll go with that. I think one more question and then we'll go for beers.
Hello.
Hello.
Why do you have such a large ego, and how do you use that as a productive part of your career?
Why do I have such a large ego? Clearly you haven't met me, or it would be self-evident. How do I use it in my career? Actually, in many respects, all jokes aside, the large ego helps me admit, in the same vein as Socrates, that I only know that I know nothing. I walk into a situation and I assume that I don't know what's going on here. And so therefore I'm forced to ask a lot of questions. And you have to have a sizable ego to be able to walk into the room and say, especially as a consultant, as a person who is viewed with some respect, to be able to say, I don't know what your problem is. Because normally you think if you hire a really, really expensive consultant, you want them to come in and tell you what to do. But I don't until I ask the questions. And in many cases, the best solutions are the ones where I ask questions and all of a sudden you go, oh, wait, that suddenly makes me think of something. What if we do this? And I go, that sounds like a really good idea. In many cases, it's not that I know the right answer. It's that I can help us get to the right answer together. but it begins with the admission that I only know that I know nothing.
So I think you know a lot more Greek than you let on, because a lot of what you've described is Greek or comes from the ancient Greeks, and that's been a great thing. Thank you for that Polytechnical talk. It was more Polytechnical than you think. I got to learn a little bit of Haskell. My young son over there will never be a programmer. Your talk was so Polytechnical that it was a great bedtime story as well. So I'm pleased.
Trust me, Haskell will put anybody to sleep.
All right. So thank you very, very much. I think Patroklos. Fantastic talk. Thank you.